Okay, folks, so you're working through your pre-work, and I'd like to do some examples now of finding the derivative of some functions where we have to use the chain rule. I'm not going to do all of them. I'm going to do example A, example C, and example F, and I'm going to leave you to do examples B, D, and E on your own. And then we'll tackle this last issue. So let's pull those up. So here we're given the function capital F of x is this function here. And I want to think of it as, let's go ahead and first think of f of x as a composite function. One function nested inside of another. So the outer function in this case would be what? And the inner function in this case would be what? So take a moment and think about those. So the outer function would be the cosine of x function, and the inner function would be 3x to the fifth. So if we want to find the derivative of capital F, by the chain rule it says take the derivative of the outside function, leaving the inside function alone, and then multiply by the derivative of that inside function. So let's actually do that with the specifics of our function. We're going to take the derivative of the outer function. Well, the outer function we said was the cosine. What is the derivative of the cosine? Well, it's the minus sine of, and then we replace this with g of x. What was g of x? G of x is 3x to the fifth. So essentially what we did was we took the derivative of the outside piece, the outer function, leaving the inside expression alone. But we still have to compensate for the change of the inside expression, and so we do that by multiplying by the derivative of that inner expression. So we're going to multiply this by a 15x to the fourth. Okay, so that was the derivative of g. So I could rewrite this as minus 15x to the fourth sine of 3x to the fifth. Okay. So in C here, I ask you to find the derivative of this function, capital F of x equals sine squared of x, two different ways. And I don't know if we've talked about this yet, so let's do so. I want to make a note here that I find especially frustrating. Math people like to abbreviate the sine squared function this way. But know that that is just shorthand for the sine of x quantity squared. And I think if you think of the entire, if you think of writing it this way, then you'll be less likely to make a common mistake with this problem. So I'm actually going to take a line to rewrite this as the sine of x quantity squared. So now I can identify the outside function and the inside function. So what's the outside function here? Well, it is the x squared function, and the inner function is the sine of x. And we can see, yep, if we plugged g of x into f of x, we would get this function here. So now we're ready to take its derivative. So we're going to take the derivative of the outer function. Well, that's the derivative of the x squared function, which would be 2 times that expression now to the first power, right? But what goes in place of that, what goes inside there, the innermost function, so we just put sine of x. So again, what did we do? We took the derivative of the x squared function, leaving the inside piece alone. But then, by the chain rule, we have to now multiply by the derivative of the inside piece. So we took the derivative of the outside piece, leaving the inside piece alone, and then I'm reminding myself to take the derivative of the inside piece. So this gives me 2 sine of x to the first, and then what's the derivative of the sine? Well, it's the cosine of x. Okay. We could clean this up. There's no reason to raise this to the first power like this anymore. So we get 2 sine x cosine x. Okay. And I'm afraid I probably didn't give you enough room here. I asked you to do this 2 different ways. Let's go ahead and do it a second way. I'm going to, let's see, what should I do? I'm just going to go ahead and let's just clear this out. So now let's look at a second way to do this problem. The second way to do this problem is to remember that sine of x quantity squared is just the same thing as sine of x times the sine of x. And then, so that's rewriting f of x. that way. So now we can find the derivative, which gives us f prime of x. Now I'm going to use the product rule. So here's the first times the derivative of the second plus the second function, which was the sine of x, times the derivative of the first, cosine x. Okay. So we've got two factors of this, and we can combine them together as 2 sine x cosine x, which is the same answer as we got before. Okay. The next one I want to do is capital F of x equals the secant of x quantity cubed. Okay. I'm not going to write out the outside and inside functions this time, but I'm going to leave you to think about what they are. So the derivative then will be the derivative of the secant of x cubed, or the secant of an expression. What's the derivative of the secant of an expression? It's the secant of that expression times the tangent of that expression, but then by the chain rule, I have to multiply by the derivative of that inside expression. So this gives me, and here I'll just go ahead and take the derivative and rewrite it all in one step. 3x squared secant x cubed tangent x cubed. Okay. So pause the video or rewatch the video. I'm going to leave you to finish out problems B, D, and E. Okay. So the very last thing I want to comment on is, why do we call this the chain rule? And I think that it's easier to see why it's called the chain rule if we look at actually a larger problem. So in this case, I've got how many functions nested inside of one another? Well, my innermost function is h of x, and it sits inside of g of x, and that sits inside of f of x. So I've got three functions. So to find the derivative of this, I'm going to have to do a chain rule inside of a chain rule. And this is our first time tackling such a problem. Okay, so here we go. We've got to do a double chain rule here, and the derivative formula says take the derivative of the outside function, so that would be f prime of, leaving the inside function alone. So what's sitting inside of f of x? This function right here is sitting inside of f of x, so that's what I've copied right here. Okay. But then by the chain rule, I'll have to multiply by the derivative of that inside function. All right, and let's keep going because we're not done. This is the derivative of the outside piece, leaving the inside piece alone. Now let's go ahead and take the derivative of g of h of x. Well, to do the derivative of this, we're going to have to again do a chain rule. So we get g prime of h of x, and now we're going to multiply that by the derivative of what was inside g of x, which is h of x. Once we clean this up, we get f prime of g of h of x times g prime of h of x times h prime of x. And maybe now you can sort of see why people call it the chain rule. What I like to do is I like to think about, it's kind of like this nested doll toys, where sitting inside of f of x, we've got this function here. So I take the derivative of the outside piece, and then I'd like to think of sort of popping out that inner piece and then taking its derivative. And now I've got another inside piece, in this case h of x, and I'd like to think about popping it out and taking its derivative. And that motion sort of is maybe indicative of why they call it the chain rule. Anyway, I hope this helps, and we'll get some practices with this in class. Thank you.